This is Biotecnika, and you're listening to India's first life science podcast, The Voice of Biotecnika.
A victory seemed even more beautiful to me when I imagined thousands of tiny photosynthetic machineries inside every leaf. Hello everyone, this is Sabha, and today I will be talking about a cocktail of medicine and genomics. It sounds interesting? It is actually. We all know that the body itself is an information processor. Memory resides not in the brain, but in every cell. So to know about the predictive medicine approach to genomics, is it a storm or not? Don't move and stay tuned. No wonder genetics bloomed along with information theory. So what is genomics? Before we define genomics, let's start by looking at the genome. Genome is a combination of genes and a chromosome. It's an organism's complete and unique sets of genetic instructions. Yes, it contains all the information that is required to build up an organism and allow it to grow and develop. What is DNA? It's a chemical code of which genes are made, of the most advanced message processor at the cellular level, an alphabet and a code, creating 6 billion bits to form a human being. So now that we know what genomes are, genomics is the study of entire sets of genes that can come from humans, plants, animals, and even viruses. Now, half a century ago, very little was known about genes. So it happened that in 1980, the National Institute of Health and Department of Energy started to work on Human Genome Project. And the sole goal of this project was to sequence the complete set of DNA in human body. The goal of Human Project was also to understand the various genetic factors that could underlie the diseases. And they were targeting that how these diseases can be prevented, treated, or diagnosed at the correct point of stage. So luckily by 2003, the Human Genome Project was completed. At this point, there was great inspiration in the field of research. Either it could be in medicine or some other field. And genomics was utilized in these fields in order to know the complete pathogenesis, the predisposition, treatment modalities, and yes, this is how the genomics was trying to serve humans. If we go and find out some benefits of genomics, what do we actually get? So, it's very true to say that genetic testing has the potential to improve our health in variety of ways by assessing health through either diagnosis, it could be prognosis, it could be risk prediction, it can be prevention, or it could be treatment. So guys, let's get started. And let's know about the involvement of genomics in medicine. Do you know that diseases can be predicted? Yes, absolutely. Predictive medicine is a subdivision of medicine field that entails predicting the probability of the diseases. And undoubtedly, big or small, it somehow brings down the adverse effects of disease on the patient, or it can also bring down mortality rate. It's really interesting to know. At this point of time, I know the questions has already been germinated in your mind. That how is it possible that you are predicting a particular disease when we don't see any signs and symptoms in the individual? So I'm here to answer your query. As you know, scientific innovations and approaches has already cracked many things. Genomics is still considered the best and fundamental way in prediction. Do you know that about 6.6 million spots are actually looked for to calculate the person's risk for developing CAD, that is coronary artery disease? Isn't that strange? So I guess it is quite justified to state now that something that has been already fixed in our cells since birth can actually stratify us into clear trajectories for a particular disorder. There has been a lot and great hunt going with cutting-edge approach by genetic contributors to certain common disease, and I really appreciate this great work done by these geneticists. Over the past 2 decades, researchers have struggled to account for the heritability of conditions that could be either related to your heart, to diabetes, schizophrenia, and many more diseases that are becoming globally epidemic these days. Guys, at this point of time, I think it's very important to tell you about that what is risk calculation. As told you earlier that Human Genome Project was a startup mark to medical revolution. At that point of time, various genetic differences was searched, decoding the differences among those with and without diseases. And these DNA letter swaps are nothing but scientifically called as SNPs, or single nucleotide polymorphic DNA. There were certain studies that were associated to study the single nucleotide polymorphic DNAs among a group of population. But again, surveying a huge population to look for the disease associated SNPs is always practically not possible. Hence, this leads to some missing heritability. And as said by Ivan Burney, who is the director of the European Bioinformatics Institute in Hinston, UK, that missing heritability is one of the major halt which genomics give to predictive medicine. So, unfortunately, the studies that are related with SNPs, population-based studies, were not able to properly catch these SNPs due to some other faults as well. So, what's next? Access to massive datasets. Access to massive datasets as well as certain data analytical tools will surely improvise even when dealing with small risk. For this, I would like to give you one example. It was set as a benchmark in predictive genomics. There was one meta-analysis done in 2015 by Catterson and his colleagues that included about 48 global studies having 61,000 CAD patients and 120,000 controls. Polygenic predictors were then tested on UK population there, and those scoring in the highest few percentiles had on average several times higher risk of developing the disease than did the rest of the population. After some time, similar analysis was performed by the group on other diseases as well. Later on, it was accepted that we can use polygenic predictors or multi-gene production rule in normal clinics also. Sticking the data into an algorithm which will provide a weight to the factor according to the strong association with the disease will be somehow beneficial in identifying the higher risk group using these polygenic scores. According to one of the famous epidemiologists at Georgia, Cecile Janssen, looking into the credibility, the performance can be improved by strongest factor linked to the disease. Means it's important to decode among all the various factors that are directly associated with the outcome of the disease. It's very important to note down the one having the strongest relationship. Do you know why? It's because inclusion of millions of variants that don't do anything could undermine the public trust in scores. At this point of time, it's important to know that polygenic scores throw out biology favoring statistics. We can't simply consider these scores as the sole determiners of drug development, but can be starting points as preliminary studies. This sort of approach will eventually decode the target genes and factors that are some way or the other involved in the pathogenesis of your disease. If I really want to sum up, I'd like to say that predictive medicine can be considered rather a new healthcare field that sounds very, very promising with a cutting edge. As a result, it is gaining significant media attention these days also. Let us know one example. We know that there are risk factors such as smoking and pollution, which are increasing the incidence of lung cancer in the population. But can we reliably predict the risk of lung cancer in an individual even if you don't know the status or previous history of smoking and pollution? Just think about it. It's not like that every person who smokes or lives next to a freeway will develop lung cancer. As a result, the current approach to preventive medicine is to universally apply one-fits-all intervention rule. Predictive medicine is a moderately new subspecialty in the healthcare system, but I think the concept is not that novel. In the most basic terms, if we talk, this subspecialty uses a specific laboratory and genetic testing to determine the probability for an individual to develop a disease, and it's really true. The last thing I would like to discuss is about issue of concerns that are really faced in predictive medicine when you use genomics and why it could be considered as a storm. So the first issue of concern related to predictive medicine and genomics is validity. Now, what is validity? Some researchers have always expressed their concerns about the validity of genetic testing, which may be because often more than one gene is involved in the disease pathogenesis. If you belong to a genetic background, you must be knowing a disease can be multifactorial in terms of genes. So there is no still single test available that is 100% sensitive and provides you 100% specificity. Hence, both false positives and false negatives are to be expected when applying any test to the predict disease. In addition to validity, students, there are certain other questions as well regarding the validity of genetic testing. Like, I hope it will be very easy for you to understand. Are the genes sole factors which are responsible for a particular illness? Or what could be the roles other factors like environment, lifestyle, food, exposure? Do they play some important role in predictive medicine? Or let's say, can we really rely on genetic testing to be the only diagnostic tool used? And what will you say when it comes to accuracy of the test? Is there any way left by which quality and validity of the test related to genetics can be ensured? I know these questions are unanswerable. So, moving on to the second con that is associated with predictive medicine and genomics. And this point is related to ethics and laws. We know that predictive medicine using genomics ushers in several ethical and legal questions. Like if you say, will genetic testing lead to judgment and shame? For example, could it lead to some people being denied jobs and insurance or losing their jobs since they have been already predicted with a particular disease? Or let's say, are there any measures by which third parties such as employers and insurance providers can be stopped from using predictive medicine data in ways that damagingly distress individuals? As I said earlier, these questions related to ethics and laws are still unanswerable. The next issue associated with predictive medicine is occupational health. Genetic testing of biomarkers definitely help to prevent occupational illness. Insurance providers claim so. But do you actually know that these new tests are raising serious questions for workers and employers both? To make this thing more clear, let's say if an employee gets dismissed just because he was found to be at risk from any chemical agent which is being used in his workplace. So what will you say? Is this termination? The termination is leading to some prevention or discrimination? Or how many circumstances would justify denying a job to a person based on his positivity to a particular biomarker? Or is there any need to develop a workplace-related genetic testing confidentiality protocols? Again, as I said, these questions associated with occupational health are also unanswerable. Last but not the least, going far down the predictive medicine path, there are several health-related issues. Like, what could be the risks and side effects associated with taking medicine before an individual gets sick? That means, just on prediction, you have started the medicine. Will that be going to create any issue in your life? How will it have an impact on the individual after being told that in future he might develop the disease? If I clearly say I'm talking about psychological consequences. Now, what about an individual's right to not know? All these questions in predictive genomics, friends, are still unanswered. And yes, this is true. With cost containment a priority in healthcare, empirical ordering of predictive tests may not be practical or realistic for the entire population. Might be in future some other developments and more reliable protocols could be designed that will be taking into consideration ethics, moral, validity and occupational issues. In that case, geneticists could actually be doing a great work in disease prediction and bringing down the adverse effect and mortality. That was all about I had to talk regarding predictive medicine and genomics. I'm leaving you guys with a question. Will predictive genomics in medicine can run in parallel in future without compromising the ethics and issues? Now, do you agree when it comes to incorporation of genetics in disease prediction or not? I really wish it could happen so that in future, without any issues, the diseases can be predicted with 100% sensitivity and specificity. Thank you for watching the video.
Should you have any questions, please comment below. Do not forget to subscribe to Biotecnika's YouTube channel and hit the bell icon to stay up to date with latest in BT sector.